Hey everybody, welcome back. Thanks for watching. So it's time to solve for another integral. It's been a big theme this week and they're a ton of fun. In order to solve the following integral, we're going to need these tools. We're going to need that classic formula we've been using. There's a proof on the channel if you want to check that out. We're going to need this classic result, right? This transformation property of sine and cosine. So the sine of pi over 2 minus x is exactly cosine of x, and the cosine of pi over 2 minus x is sine of x. And we're going to need some clever algebra, but nothing too terribly tricky. So with that said, let's get into it. It's quite a cool problem. Okay, so here we go. This is the problem that we want to solve. So we've got the integral from 0 to pi over 2. We've got sine of x minus cosine of x over 1 plus the product of sine of x and cosine of x. dx, of course. So step one, we're going to use that classic result that this equals this. Okay, so let's go for it. So that means that I can really think about our original integral in this way. So this is the integral from 0 to pi over 2. I've got sine of, well, a plus b would be, well, pi over 2 minus x minus the cosine of pi over 2 minus x. That's all over 1 plus the sine of pi over 2 minus x times the cosine of pi over 2 minus x dx. Okay, so we know by our transformation properties this is exactly cosine of x, this is sine of x, this is cosine of x, and this is sine of x. So let's note that. Oops, we said that's cosine. I should stick to my word here. We said that's cosine. So that's cosine of x, and we said that's sine of x over 1 plus cosine of x sine of x. Okay, so the thing that we want to note is that this integral equals this integral. So I'm going to take a little side step here. So I'm going to say that 2 times the original integral, that's the same thing as doing the original plus itself, right? So 2 times the original integral I could really think about it as, so this means this plus itself. However, this and this are equal. So that means I could really think about this as a copy of the original, right? So a copy of the original integral. And instead of writing plus itself directly, since we said that this is equal to this, we're going to say this plus this, which again is equal to that. So hopefully you can see where we're going, because then we want to take note that the integral is additive and also will have common denominators. Okay, so that's looking pretty good so far. Now, the integral is additive, so what does that mean? Well, that means that I can write this as a single integral. I've got common denominators, so I just need to add the numerators. But if I add the numerators, I get 0. So this is the integral from 0 to pi over 2 of 0 dx. And of course, that's equal to 0. And so if 2 times the original integral is 0, just by dividing both sides by 2, that implies that the original integral is actually 0. So thus, the original integral is equal to 0. What a cool problem.